In this video, I'm gonna cover calculus 2, something like function of x multiplied another function of x. So let's say you have f of x equal to x raised power of 2 or x squared. Here is multiplication, and then secant hyperbolic, h is hyperbolic of x. So you have this function times this function, and then the question is find the derivative of this function. So the df with respect dx or df dx equal to, so normally call 2 when you have a function that multiply another function. So basically what you're gonna do is the you do the derivative of the first function, and you multiply for the other function, and you add, and then you do the multiplication of derivative for that function, and then you add the other one. So basically multiply the function of x. This is the function of x, right? So basically what you're gonna do is you do this function, and then you do the derivative of this plus, and then you do this function, and then you do derivative of this. That's how it works. So the the df dx equal to x squared, and then we have to do derivative of this. So the secant hyperbolic of x, if you do derivative of this, there is a table you might be given. So derivative of this is equal to the secant hyperbolic x times tangent hyperbolic x. So derivative of this is this. So you do the first function times derivative of this. So we did this, and then you add. Now you do the second function is this secant hyperbolic x and derivative of x squared. Derivative of x squared is equal to 2x, for calculus 1, because the exponent coming, you multiply to the x, and then the exponent here is 2, you subtracted 1, so it will be the 2x. So now once you do the derivative, now you have to simplify. So simplify. This is coefficient 2, it comes in the front. You can rewrite, organize it. So you can say this coming to the front, and then you can say 2x with secant hyperbolic x. This is hyperbolic, so I will be covering this calculus 2. 2x secant hyperbolic x minus, and then the other expression, x squared secant hyperbolic tangent. So this is how you do. So basically this is when you do the derivative, and this is when you have to simplify, where you just reorganize it. Let's do another one. F of t tangent, let's say f of t and tangent e to the t, right? E to the t, kind of like a chain rule. So f of t tangent hyperbolic e to the t. You have to find df dt, right? df dt equal to, so we have to find, like I was saying, uh, the tangent itself is what is the secant hyperbolic. This also goes to the table. So you do the derivative of the tangent. What are you gonna get? Secant hyperbolic, secant hyperbolic square e to the t, right? This is the derivative, and then we have to do derivative inside. So derivative inside, anytime you have, this is the kind of like complex number, so e to the t don't change, so it stays e to the t anywhere you see. So derivative of this is e to the t. So now I was saying earlier on, you have to rewrite, it comes to the front, e to the t. So you have derivative of diff e to the t secant hyperbolic e to the t. So this is the Cal2, and normally how you will know tangent and with all these angles, which might be changed to the, the angle, x of function e to the t, t, anything that mention it. But you're gonna have a table that shows you, like I think I cover the trick. If you look at my video trick, sine is equal to sine angle equal to cosine. The inverse of sine is 1 over cosec angle. So same thing, Cal2 with all these derivatives, they have a table. So I'm trying to limit my video, make it short. So once you get that table and you figure out how you move around, it will be understandable.